Okay, this is our Math 1113, 8 o'clock Zoom meeting. I hope everybody got the video from yesterday and you're watching it. And if you email me the secret code, I'll give you 5 extra points on test 2. This week we're doing sections 5.4 and 5.5. We'll try to give you a brief introduction to them. Section 5.4, how to undo functions. Sine, cosine, and tangent. So this comes up when you want to solve sine x equals a half. And so what happens is you need to undo sine. If you look on your calculator, right above sine, you see the sine minus 1. Same thing with cosine, a cosine minus 1. Tangent, tangent minus 1. Okay, those functions that undo what's on the key, they're paired on the key. Just like square root and x squared undo each other. And back to first chapter, ln and e to the x undo each other. Log and 10 to the x undo each other. Your whole calculator is organized this way. So you take, it's called inverse sine, or you'll see the term arc sine on both sides. So inverse sine of sine x is supposed to be x. But there's a problem. The problem is it does not work for all x. Unlike square root of x squared works for all x, and ln of e to the x works for all x. But, and I've frozen. Let me, everything's frozen, so let me stop the share. Oh, we're back. Maybe. Maybe not. Not working like a well-oiled machine today. Let's stop the share. And see if we can restart it, get it going. Okay. screen is blank. Let's try it again. Okay, hopefully we're back. It was, yeah, I don't know, internet problems this morning. Okay, so square root of x squared, they undo each other and it works for all x. Log of e to the x works for all x. Okay, but arc sine of sine of x, arc cosine of cosine of x, arc tangent of tangent x do not work. No, you're supposed to get x, but they do not work for all x. They only work for x in the domain of the inner function. Here. And you can see why. We'll walk through the sign in real close detail. This is where they haven't really done graphs of these. So I'm not really sure how they expect you to do it, but I guess I'll just put up a graph of, because you can really see it from that, even though they really haven't covered graphs of these yet. All right. You want to be in radian mode. You 10, 10, 1. You 10, 10, 1. Okay. And you want to be, put in a sine of x and I'm freezing again. Okay, maybe I'm back. Okay, maybe I'm back. Make sure in mode. Yes, I'm in degree mode. I'm going to be in radian mode. And so when I hit graph, let me come down and I'll put in -1 to 1. So I stuck it in radian mode. Okay. Graph of sine looks something like this. I haven't really covered why it looks like this. Maybe I could do that really quick for the sine. I'd really like to get into some problems with our internet problems for a long time this morning. But if you'll notice, it goes through the origin, goes up and peaks. It looks like a wave. They refer to this as sine wave. This, by the way, you can hook a meter up to your wall socket, and this is the exact picture of the voltage of electricity that comes out and powers every one of your electrical devices out of an outlet. Go ahead and draw. They call this a sine wave. I haven't really covered why it looks like that. What you're doing, remember, this is the y coordinate around the circle. So maybe I'll quick graph to show you some numbers. You'll have to have some of the numbers, coordinates memorized. Sine of x. This is the y coordinate. 0, sine 0 is 0. If you relate this to the circle, remember you start at 0, 1. I'm sorry, you start 1, 0, and we'll just do the 3, 30 degrees, 5 or 6. Your coordinates were root 3 over 2, and 1/2. It's 0.5. You'll need decimals for this. 0.5. Here you were root 2 over 2, root 2 over 2. Root 2 divided by 2. Each one is 0.707. So at pi over 4, you're at 0.707. At pi over 3, your short side's a half, long side's root 3 over 2. And root 3 over 2. .866. See how you're rising to 1, and then by 90 degrees, I'm sorry, pi over 4 was just this one. This was pi over 3. And then by pi over 2, you're up to 1. You're up to 0, 1. So if you draw a quick graph by hand, 0, 0, pi over 6, you're up to 1/2. Pi over 4, you're up to 0.707. Pi over 3, you're up to 0.866. And by pi over 2, you're up to 1. And if you go backwards, these values repeat. I won't write them all down, but these values repeat, and you get this. And then as you go past pi over 2, the values come down to the same values, but your angle's increasing, but your values are coming down. And by pi, you're back to 0. And the wave just continues on around. All right. The point being for this section is the test for inverse is a horizontal line test. Remember, the test for function is vertical line test, and it passes that. Vertical line only cuts through this once anywhere. But when you go to inverse, you switch x and switch x and y, and your vertical line test becomes a horizontal line test. And you can see this spectacularly fails. This is arc sine x with a domain from -infinity to infinity. And you fail, it cuts infinite places, because this graph goes forever. You have multiple output. Remember, this is now the input, this is now the output, and you have multiple outputs for any input. So this was we'll call this version 1.0. Pure sine of x with a domain -infinity to infinity has no inverse. It fails the horizontal line test. So version 2.0, you can see you can cut it here and here. And it turns out this is at the top part of the circle where you're 1, so you're pi over 2 here. And this is going to be at negative pi over 2 down at the bottom half circle. Version 2.0, y equals sine x. It's called the domain restriction. Your domain runs from minus pi over 2 to pi over 2. The range on that, you remember, that's x min, x max. Range runs from -1 to 1. On the unit circle, remember, you never get around 1. Never get above 1, never get below 1. Okay, so rewrite it up here if I keep it in line. Y equals sine of x. And to have an inverse, use domain negative pi over 2, pi over 2, range -1 to 1. To have an inverse. If you remember, so for y equals arcsine of x, domain and range switch for the inverse. Basic college algebra. That's because you've switched x and y. Remember, this is your x's, this is your y's. To have an inverse, you switch x and y. And that means the domain of your original is the range of your inverse, and the range of the original is the domain of the inverse. So in other words, y equals arcsine x. It has a domain of -1 to 1. The range of this, and it has a range minus pi over 2 to pi over 2. This is hard to explain in a regular class. This is my first time trying to explain it online. So yeah, it's very technical here. Bottom line. We'll punch the keys in this order. Arcsine of sine of x equals x for x in domain of sine of x, the inner one. The domain of sine is this, from minus pi over 2 less than or equal to x less than or equal to pi over 2. Basically the right half circle. And number 2, if you reverse it, sine of arcsine of x, that equals x, but now you're looking at domain of arcsine. That's -1 less than or equal to x less than or equal to 1. Or x in domain of arcsine. You've got to pay attention to this because they're going to try to trick you in the homework and make you work these things out, but the x will not lie in the right domain, in which case it's undefined. We'll show you that if I get to the homework here, because I got 2 others to do. I got cosine and tangent to do. To give you some confidence, hopefully give me some confidence in this. Let's see if they write this down. Well, for sine, arc sine, show you this off the book. Arc sine, domain -1 to 1, and range -pi/2 to pi/2. You barely see that, so it's so blurry. But there it is, range -pi/2 to pi/2. Okay, I'm going to try to speed this up through arc cosine and arc tangent. Cosine. This is number 2. Y equals cosine of x. Turns out the graph of cosine, you can draw it. I'm going to speed it up, but starts high. Same kind of wave as sine, but it starts high on the y-axis and goes this way. Again, fails horizontal line test. They restrict it here and here. So version 2, here to here. And it turns out this is at 0 and this is at pi. So we're taking y equals cosine x with a domain 0 to pi. Its range is still -1 to 1. Notice I'm using brackets on all these because all these values are included. Y equals arc cosine x, therefore has a domain -1 to 1, and range 0 to pi. Top half circle. The domain on a cosine is top half circle, top half circle on the unit circle. So punch the keys in this order. An arc cosine of cosine x, that equals x. If x is in the domain of cosine, x in domain of cosine, and that means 0 less than or equal to x less than or equal to pi. And cosine of arc cosine x, that equals x in a domain -1 less than or equal to x less than or equal to 1, domain of arc cosine. All right, we'll show you in the homework where you have to pay attention to this. Like I said, it gets very technical. Third one, really quick, write down. We'll try to get to some homework. Tangent. Turns out tangent graphs look like S curves. Series of S curves. Why they have you do this without showing you the graphs, I don't know. Again, fails horizontal line test. We use the middle. And it turns out tangent's very similar to sine. Use y equal tangent x. The graph will be this middle one. Goes between these asymptotes, and it turns out this is at pi/2 and -pi/2. And this is going to use parentheses, domain -pi/2 to pi/2. Notice I'm using parentheses, it turns out, because remember tangent, sine over cosine. Well, at pi/2, your cosine is 0, and it blows up. So it does not include -pi/2 or pi/2. Range, turns out, is -infinity to infinity. Remember, it's the ratio of the y leg to the x leg, so it can go all the way from, there's no rules on it, -infinity all the way up to infinity on it. Y equals arctangent of x its domain then is minus infinity to infinity, which means you can stick anything into an arctangent. You can stick any number in an arctangent. Can't spell arc, ACR. Arctangent. All right, and its range is minus pi over 2 to pi over 2. The domain of tangent. Okay, yeah, that's what they have. Okay. You got to keep all these, but you don't really have to memorize them. You just have to realize this is what's going on. It's tough to memorize. I can't hardly memorize it myself. Let's try a few homework problems. Make sure I get them off what I assigned you. So 5 to 37 odd, section 5.4. We had 5 to 37 odd. So these are off page 472. Okay, they start with problem 5, part A. Arc sine of 1. Okay, you can, it says express your answer in radians. It says find the exact value. To be honest, you can use your calculator. You're online, you're at home. In the class, I could, make you put your calculator away and do it straight. So yeah, you can literally punch this. They said express your answer in radians. I'm sure it's still radian mode, I am. Second sine is what gives you the arc sine of 1, and you're getting 1.57. You see how many places? Express your answer in radians. Now I'm supposed to find that answer exactly. This is the decimal approximation. Okay. Try to best to explain how to get the answer, exact answer, because it turns out this is pi divided by 2. All right, so where that comes from is, you can call this an angle. If an angle is equal to arc sine of 1, the sine of this angle, take the sine on both sides, is sine of arc sine of 1. All right, well, the first thing you should check, is this in the domain? Is this in domain? All right, if you look back, I'll show you, bring up those domains again. You're looking, is 1 in the domain of sine? Actually, arc sine. And if you look at arc sine, yes, 1 is in the domain. You're right at the extreme edge of it, but it's in. 1 is in. Yes. Yes. So sine of theta equals 1. In other words, you're looking, the sine of theta, if you remember, was the y coordinate. So you're looking for the angle where y coordinate equals 1. Quick draw on the circle. Remember, up at the top, you're at 0, 1. That angle is pi over 2. So theta equals pi over 2. And you can say, in other words, the sine of theta, here in this case is sine of pi over 2, equals 1. If you do arc sine of pi over 2 equals arc sine of 1, this cancels because it's in the round. Pi over 2 is in the domain of sine. The arc sine of 1 equals pi over 2. I know that's a lot of gibberish, which is why when you're at home, I can't keep you from using a calculator. We can try one like 7a. Arc sine of 1 equals pi over 2. All right. Maybe I'll try the gibberish on 7a. Arc sine of negative root 2 over 2. And I'll call this an angle. Any arc anything turns out as an angle. You're looking for angle where the y coordinate is negative root 2 over 2. Well, if you remember, this occurs at 45 degrees, but it's negative. It's in third or fourth quadrants. Okay, so in other words, if I draw 45 degrees, or pi over 4, you really want radians, so you really want pi over 4 here. Your total angle around is actually 5 pi over 4, because your pi over 4 bigger than pi. Remember, at pi, you'd be at 4 pi over 4. You're really 5 pi over 4, and your pi over 4 short here. So you're really, this would be at 8 pi over 4, 2 pi. 8 pi over 4. This would be 7 pi over 4. Okay. You would have your y coordinate here, negative root 2 over 2, negative root 2 over 2. The answer is neither. Five pi over 4 or 7 pi over 4. Why? They're not in the range of your arc sine. You want an answer in the right half. But it must lie between minus pi over 2 and pi over 2. Minus pi over 2 to pi over 2. So your actual answer, your theta, is negative pi over 4. You actually want negative pi over 4. It's in the range of arc sine. You're getting it. This is your input in the domain. It's in the domain of arc sine. Your output's got to be in the range of arc sine. Range of arc sine was negative pi over 2 to pi over 2. It's tough to keep writing these down every page. negative root 2 over 2 for arc sine. Your domain was negative 1 to 1, and range is negative pi over 2 to pi over 2. I'm out of paper. Oops, wrong page. Domain was negative 1 to 1. This is for arc sine. Range, negative pi over 2 to pi over 2. Root 2 over 2 was 0.707. Root 2 over 2, I punched it when I showed you the graph, 0.707. So it's in the domain. So it's a legal domain. Your output has got to be in the range from minus pi over 2 to pi over 2. So we got to call it negative pi over 4. Off the paper. Not 7 pi over 4. Because it's got to lie between negative pi over 2 and pi over 2. Give you some confidence in this. See if I'm an idiot. 5.47a. Negative pi over 4. There it is. Right there. 7a. Okay. The next section, they want a calculator value approximated to 5 places. Again, some of these can be punched and some of them, they're tricking you. Try problem 9. It's off page 472. Arc sine of 0.3. Second sine, 0.3. I'm still in radian mode. 0.30469. All right. These are not just random values. If you want to interpret this, this is the y coordinate. This is the angle. So what this is saying is that an angle of 0.30469 radians, it said 5 places, but I don't really care about the 5 places. I mean, I'm not that picky. Your angle is 0.30469. You have a y coordinate of 0.3. Your hypotenuse is 1. Okay, if you want to check this, take the sine of 0.30469. It should be opposite over hypotenuse, which should be 0.3. Let's see how close we get to it. Sine 0.30469 comes up 0.299, almost 0.3. And arc cosine would give you an angle, and this would be an x-coordinate, and arc tangent would be the ratio of the two. I could also ask you what the x-leg is. You can do it by Pythagorean theorem. You could also do it by cosine. The x-leg, cosine of 0.30469 would be x over 1, which is just x. So if I took the cosine of 0.30469, 0.9539. And guess what? If I took 0.9539 squared and add 0.3 squared, guess what I should get? Add 0.3 squared, it comes up 0.9949 is 25. Yeah, pretty close to 1. It's all internally consistent. It makes perfect sense to me. 15, trick. An arc cosine of 3. Wow, big deal if it's a rank amateur. So just try to punch it. Second cosine of 3. Oh my goodness. Domain error, doesn't matter. Domain, out of domain. Domain of arc cosine was the range of cosine. Instead of flipping back, I'll puzzle out what it was. Domain of arc cosine equals the range of cosine, and that was -1 to 1. See, 3, clearly not between -1 to 1. You just write down undefined. Okay. 17 to 22 is about finding angles. 23 real quick. It says find all angles. Sine theta equals 2/3. Find all angles between, now they're really restricting things, between 0 degrees and 180 degrees. So you want degree mode. And you want to do an arc sine of sine theta is an arc sine of 2/3. Yes, 2/3 is between -1 and 1, so you're okay. Should be checking that. Switch to degree mode. Okay, degree mode, and you want to do an arc sine 2/3, 41.81 degrees. Okay, this is where things get technical. And again, the diagrams to me help. 41 degrees in the first quadrant, 41.81 degrees. You just found the y coordinate of being 2/3. All right, this is off, this angle, the 41 is directly off the calculator. It's only going to give you an answer. The calculator is programmed to give you answers in the range of arc sine on the right half circle, but it wants all angles. To find the other angle, you draw your unit circle. All right, well, where is the other place around the circle that would have a y leg of 2/3? Well, it's got to be over here. You'd have 2/3. In effect, the calculator is programmed to give you the reference angle, 41.81 degrees. So the other angle will be 180 degrees, subtract 41.81 degrees, which should be and again, this doesn't have to be done in degree mode. This is simple arithmetic. You could do this in in radian mode as well, and you're going to get the same answer. 138.9 degrees. If you want to check, take the sine of 138.19 degrees. .6665 of them, blah, blah, blah. That is basically 2/3. Pretty sure the book is going to report both answers Double check again, 5.423. .41 degrees, 138. It said rounded to 10th place. I didn't pay attention to that. 41.8 and 138.2. There's my 41.8 and 138. They rounded it to 2. I'm not that picky about the rounding. I won't trick you on a quiz or anything, true or false. If I'll try to make it more obvious than that. I have got to get ready for my 9 a.m. Zoom meeting. So we will pick up with this and try to finish through 5-4 at Friday's Zoom meeting. So I will end this meeting and get ready for the 9 a.m. Zoom meeting.